The world is running on fuels. Of course, Earth rotating itself without consuming energy, but every object on the Earth's surface required energy to move. The fuels are the best energy sources among available. So I am Dr. GSR. This is my channel. Today our topic is fuels introduction. You can watch all different topics in my channel. The links are provided in the description. So, what is energy? The strength required for sustained a physical or mental activity. We all know energy in different forms. So we know heat energy, electrical energy, chemical energy, kinetic energy, potential energy, different types of forms for the energy. Okay. So today we are going to discuss about the heat energy that produced by the fuels. So what is a fuel? Fuel is a chemical substance which on combustion it produces large amount of heat energy. So that's why fuel is a source for heat energy. A substance, any substance, if which on combustion produces large amount of heat, that substance is called fuel. So fuel is a chemical substance, remember it. So what is the difference between chemicals and fuels? So chemicals and fuels. So fuels, all fuels are chemicals. For example, we know the different types of fuels, petrol, that is called also gasoline, and diesel, kerosene. These all are the fuels. Yes, they will when they are burned, they produce large amount of heat energy. But they itself chemicals. Petrol consisting carbon-carbon bonds, carbon-hydrogen bonds. These are chemicals. But all chemicals are not fuels. For example, chalkpiece, telephone, these also having polymers, chuckpiece having calcium oxide. So these things there, but these never become fuels. Why? Because on burning they doesn't produces large amount of heat. Instead of heat, they produces different things, and of course to burn them we require more energy. They never become fuels. Okay, so fuels produce heat energy. That's why they are source for heat energy. That heat energy can be used in domestically and industrially for different purposes. Mainly fuel consisting of carbon, hydrogen, and oxygen as main constituents. But a fuel may also contain impurities like sulfur, nitrogen, of course, moisture. Okay, these are the constituents present in the fuel. So, what is combustion? So a fuel is a chemical substance which on combustion produces large amount of heat, But what is combustion? Nothing. So if you burn anything in presence of oxygen completely, that process is called combustion. Burning of something completely in presence of oxygen is called combustion. So fuel, when combustion in presence of oxygen, that means when burned completely in presence of oxygen, it produces heat energy, and also it produces combustible gases and non-combustible matter. You can see here, when the fuel is burned in presence of oxygen, it produces large amount of heat energy. Along with the heat energy, it also produces combustible gases. These are the combustible gases, and non-combustible matter like ash. When we burn the wood, it also produces heat energy and combustible gases like CO2, and also produces ash at the end of the process. So these are the main things you require to remember, these things: combustible gases, non-combustible matter, and heat energy. This non-combustible matter is called ash. Why it is called combustible product? Why it is called non-combustible matter? So fuel mainly consisting of carbon, hydrogen. When carbon interact with the oxygen, it produces the carbon dioxide. So it is and H2O vapors. These are come as a combustible gases or combustible products. Okay, that means they are involved in oxidation process. They are involved in the combustion process. Carbon plus O2. When carbon completely burn in presence of oxygen, then CO2 is producing. That's why it is called. That's why it is involved in combustion. That's why it is called combustion product. But non-combustible matter mean the fuel contains some compounds which are not involved in combustion, and they retained as a react products. That means they are doesn't involve in combustion, they retain in the final product. Those are called non-combustible matter. So how fuels producing large amount of heat energy? So I am already told fuels are nothing but chemicals. Chemicals having different atoms are combined in a covalent bonds. When you break covalent bond, it produces large amount of heat. So like that, fuels contain different types of bonds. When you break, it produces large amount of energy. That energy in the form of heat released in the fuels. That's why they produce, and that's mean the chemical energy present in the fuels is converting into heat energy on combustion process. So classification of fuels. Fuels can be classified in two types. One is based on their occurrence and another one is based on their physical state. So first one is based on their occurrence. So if the fuels are naturally available, those are called natural fuels, and the fuels are prepared from the naturally available fuels are called derived fuels or artificial fuels or secondary fuels. Of course, natural fuels are also called primary fuels. So primary fuels are naturally made fuels. We no need to prepare them. So we just find the where they are available. Okay. And next one, second, artificial fuels means we can modify the natural fuels. We can modify the natural fuels according to our usage. Okay, those are called artificial fuels. So examples are wood, peat, ignite, crude oil, natural gas. These all are the available fuels on the earth surface or at the crust. Okay, so these are called natural fuels. And artificial fuels means wood, charcoal, coke, kerosene, petrol, diesel, water gas, LPG. These are all called artificial gas. Why they are called artificial gas? We can prepare coke, charcoal from the wood. Wood is a natural product. So from that wood we can prepare coal and charcoal. Crude oil or petroleum is a natural fuel. We can prepare kerosene, petrol, diesel and alcohol from the natural fuel. Natural gas is a natural fuel. We can prepare LPG, CNG from the natural gas. That's why these are called man-made fuels, artificial fuels, or secondary fuels. And next classification is based on physical state. Physical state. So according to their physical aggregation, they are divided into three types: solid fuels, liquid fuels, and gaseous fuels. So solid fuels mean so all wood, charcoal, coke, peat, all are come under solid fuels. Liquid fuels mean the fuels which are in liquid state: petroleum, crude oil, petroleum, sorry, kerosene, petrol, diesel, alcohol. These all are example for the liquid fuels. And finally, gaseous fuels: natural gas, LPG, CNG, water gas, producer gas, and biogas. These all are the example for the gaseous fuels. So this is the classification of fuels. And so fuel, we know fuels are the source for heat energy. That's why we need to require to know the units for the heat. Heat can be measured by calories or kilocalories most often. So what is calorie? The amount of heat required to raise the 1 degree centigrade temperature of the 1 gram of water. For example, if you take a 1 gram water in a beaker, you can measure the temperature of water, 1 gram water before starting the experiment. So just now you measure the temperature, that is T1. If the temperature is 25 degrees centigrade, so if you want to make the temperature into 26 degrees centigrade, how much heat you should be give to that water? That energy is called calorie. So 1 gram of water, 1 degree centigrade. To raise the 1 degree centigrade of temperature of 1 gram of water, the required heat energy is called calorie. The same way, kilocalorie means the amount of heat required to raise the 1 degree centigrade of temperature of 1 kg water. If 1 gram water, it is calorie. If it is 1 kg water, it is called kilocalorie. Okay. 1 calorie is equal 1000 kilocalories. Just very simple. 1 calorie is equal 1000 kilocalories. So another units is there: British thermal unit and centigrade heat unit, BTU and CHU. So BTU means the amount of heat required to raise the 1 Fahrenheit temperature of 1 pound of water. So just units are changed for the weight and temperature. 1 Fahrenheit and 1 pound water. Okay, so just like 1 degree centigrade, 1 gram of water. Here they are consider 1 Fahrenheit of 1 pound of water. Then it is called British thermal unit. Next one is centigrade heat unit, 1 degree centigrade of temperature of 1 pound of water. They mixed the units, 1 degree centigrade, 1 pound water. That is called centigrade unit, heat unit. Okay, these are the units for heat, but most ofly we are using calories or kilocalories. Okay, so next, what are the characteristics of good fuel? We have different examples for fuel, but which fuel is good one? So we know the equation for fuel. When the fuel combustion, that means completely burned in presence of oxygen, it should produces heat energy, large amount of heat energy. Then only we can call it is a fuel. So for example, if it is producing very less heat energy, but it is producing more combustible gases and non-combustible matter, that is a bad fuel. Okay. So which makes the fuel good one? What are the characteristics of good fuel? So let's see. First one is higher calorific value. So calorific value is the capacity of heat generation of a fuel. The fuel, how much it is producing heat energy. So we already know the first and best characteristic of a fuel is producing large amount of heat energy. If it is produces more heat energy, it has more calorific value. That's why a good fuel should have higher calorific value. Okay, for example, if you take solid, liquid, gases, so compared to solids and liquids, gases fuels produces the large amount of heat energy when they are taking in similar units. That means if you take 1 kg gas, 1 kg liquid, 1 kg solid fuels, the gaseous fuel produces large amount of heat energy. That's why gaseous fuels having higher calorific value. And second one is moderate ignition temperature. Ignition temperature means the initial heat energy required to start the combustion process. Even though fuels producing large amount of heat energy, to start combustion process, we need to initiate it. We need to give some heat energy or some temperature to the fuel. Then only they start in combustion process. That initial temperature is called ignition temperature. That ignition temperature should be moderate for the ideal fuel. If the ignition temperature required high amount, that means you need to give more heat energy. So that is not ideal for the good fuel. And another thing is, if you giving very less amount of ignition temperature, then also fuel is involved in combustion, it is also not good. Why? Because they are easily involved in fire accident. Okay, they are explosive nature. So that's why ignition temperature should be in moderate range. Okay, for example, if you take solids, gases and liquid fuels having moderate ignition temperature, but solids require high ignition temperatures to start to combustion process, and gases fuels require very less ignition temperature, they easily catch fire. Okay, so next third one is moisture content. So if a moisture having fuel, for example, if you take a wet wood and dry wood, which easily involved in combustion, which produces more amount of heat energy, which produces more amount of combustible products. For example, if you burn a wet wood, instead of heat, it producing large amount of smoke because of there is a moisture in the wet wood. So moisture percentage should be low in a good fuel. That's why good fuel should contain low moisture content. Okay, and next one is non-combustible matter, low non-combustible matter. So as I told, heat energy should be high, remaining 2 hours should be low. They should be low, that is the good fuel. So non-combustible matter like ash, it should be produced after the combustion. So non-combustible matter. For example, if you take the wood, liquid, wood, petrol and LPG gas. If you burn the LPG gas, you are unable to see any ash. It produces, but we are unable to find the ash at our homes. Okay,
So there is a liquid petrol. When you burn the petrol in the or diesel in the combustion engines, at the exhauster we can find the smoke ash, that is called combustible matter. But when you burn the wood, you can easily identify the ash, large amount of ash. So non-combustible matter, solids are producing very high non-combustible matters compared to liquids, but ideally gaseous fuels produces very low non-combustible matter. So that's why a good fuel should contain low non-combustible matter. So next one is moderate velocity of combustion. That's mean moderate velocity of combustion mean if you start the combustion process of a substance, it should produce orderly. It not involved in combustion at a time, total object involved in at a time, and we are unable to control the speed of combustion. It is that produced heat energy will go, there is a chance to go as a waste. Okay, if you burn wood, how much heat energy can you use at a time? So some of the heat energy will be waste. It easily interact with the atmosphere. Loss of heat energy is more when you burn the wood at open places. But when you burn LPG gas in a stove, you can control the combustion rate by increasing, when you put in slim, when you put in high, you can control the speed of the combustion rate. So that's why a good fuel should have moderate velocity of combustion, and also it can controllable. Okay, and sixth one is less toxic combustible gases. So less toxic combustible gases. So every fuel produces combustible products. Why? Because every fuel having carbon, hydrogen, when they burn, they interact with the oxygen and they produces carbon dioxide, carbon monoxide. If the fuel contains sulfur and nitrogen, they are also producing sulfur oxides and nitrogen oxide. They are the very toxic. Okay, every fuel produces combustible gases, but that combustible gases should not toxic or less toxic. That means if a fuel contains sulfur and nitrogen, they produces toxic gases. But if the fuel doesn't having any sulfur nitrogen traces, it only produces either CO2 or CO. CO2 is a not much toxic than the other gases. So like that, a good fuel should not produces, or it should produces less toxic combustible gases. And next seventh one is the fuel should be readily available and available in low cost as a bulk. So fuel should be available in low cost. Okay. And handling, transportation, and storage should be easy. These are the good characteristics of a fuel. So now may ask, compare the solid, liquids and gaseous fuels characteristics. So I already explained during the characteristics of fuels. So we have a three types of fuels: solids, liquid, gases. Just ignition temperature is very high for solids. Liquids should be moderate, and gases require very low ignition temperature. That's why in the point of ignition temperature, liquids are good fuels. Okay, liquids are good fuels. And calorific value mean the total amount of heat liberated when fuel and unit fuel is completely burned. When unit fuel is completely burned, how much heat energy it is producing, that value is called calorific value. I will explain in the later session what is calorific value and what is types of calorific value. So in terms of calorific value, gas is producing very high calorific value compared to liquids producing high calorific value compared to solids. That's why gaseous fuels are best here. And moisture percentage, so moisture should be high in the solid fuels only. So solids may contain high percentage of moisture. So according to moisture also, gaseous fuels only best fuels. Why? Because a good fuel should have low percentage of moisture. Next, combustible gases and toxic gases. So gaseous fuels produces low toxic gases. That's why it is good fuel compared to liquids and solids. So in case of solids, it also producing very high toxic gases, and liquids also producing high amount of toxic gases. And non-combustible matter, again solids producing very high non-combustible matter. So it producing liquids producing low, and trace amount of combustible matter, non-combustible matter produced by the gas. That's why these are the best fuel compared to the solids and liquids in the point of combustible, non-combustible matter. Okay. So next one, combustion rate. You cannot control the combustion rate of solid fuels. Why? Because barely. So solids are openly fired up. You cannot control the combustion rate. But liquids and gases always we operate by the instrument. So instrument, because of instrument you can control the rate of combustion, right? And cost and availability. So this is the point. So where the positive point for solids. So solids are low cost and easily available. In this point, according to this point, solids are good fuels, but liquids and gases available, not available easily, and they have much cost than the solids. And storage. So solids are easily storable. If you have a shed, you can easily store these solids. But liquids and gases, you require special operators to store. So that's why separation storage is very difficulty for liquids and gases. And transportation. So transportation for solids is very hard. You require more labor, but by using technology, you can easily transport the liquids and gases through the pipelines without using much labor. So this is the comparison for the solids, liquid, and gases. And question may also ask like this: what is the merits and demerits of the solids? You can see here almost all are demerits for the solids. Demerits for the solids. Only merits are their cost and their storage. These only merits. Remaining all are the demerits. If you see the liquid part, there is a demerits. These have a moisture combustible gas is high and non-combustible matter is low, and high cost. Okay. And storage also difficulty. These are the demerits, but merits are moderate ignition temperature is merit, calorific value is a high, it's merit, and combustion rate is controllable, is a merit, and transportation is a easy, that's also merit. If you see the gases fuels, everything is merit. Low ignition, like ignition temperature is low, it is a demerit, right? So remaining are very high calorific value, very very low moisture, very very low toxic gases generation, and non-combustible matter also producing low. It is controllable combustion rate. These all are the merits, and also it is easily transferable. It is also merit. Remaining two, their cost is very high and their availability is very less, and their difficult to store. These are the demerits. Like this also make question ask like this, same the points I write here again. Merits and demerits of each solid, liquid, and gaseous fuel. So this is the demerits of liquid fuels. Okay, like that gaseous fuels. Gaseous fuels having high merits than the demerits. So only production cost, and they are unsafe for use. They are inflammable because they are low ignition temperature. They are inflammable, easily fire catchable. Okay, the risk during transportation and storage, that is also important point. So this is the topic for today. So fuels introduction, characteristics of good fuel, classification, characteristics of solid, liquid, gaseous fuels we discussed in this topic. In next topic we discuss about the what is calorific value, types of calorific value. And thank you for staying with me. Thank you very much. Bye.